Okay guys, so it's time for math. So what I want you to do first is I want you to get out today's packet for Thursday, April 30th, and then open to the first page, and you have your customary weight conversion chart. And then on the back, you of course have the reminder. From big to small, you multiply, and from small to big, you divide. So go ahead and get this conversion chart out. Tear it out of your packet, because remember, do not turn it back into me. And then also go ahead and get out this chart from yesterday, the one that has each type of each unit, and it tells you from lightest to heaviest. You need both of these charts out today to help you with this lesson. And before we begin the lesson, let's go ahead and look at this conversion chart. So you should be looking at yours. We know that the units in order from smallest to largest are ounces, or OZ, then pounds, or LB, and then tons, or capital T. Remember, we're not lowercase t, but capital T. So, ounces are the smallest. That means there, of course, are no pounds or tons inside an ounce. However, in 1 pound, you have 16 ounces. So that means 1 pound and 16 ounces are the exact same weight. If you held them or put them in a balance, it would be the exact same. You can fit 16 ounces into 1 pound. If we think of it like the examples of these units that we learned yesterday, 16 ounces would be equal to 16 slices of bread. 1 pound would be equal to 1 loaf of bread, which we know there's about 16 slices of bread inside 1 loaf. Now we have 1 ton, which is the same as 2,000 pounds. That means you could fit 2,000 of those loaves of bread on a balance, put an elephant on the other side, and they would be equal. So imagine that balance. For pounds and ounces, on one side you've got 16 loaves of bread or 16 strawberries. On the other side you've got On one side you have 16 slices of bread or 16 strawberries. And on the other side, you have a loaf of bread or a pineapple, and they will be equal. They will be balanced. They will not be unbalanced because they are the exact same. Then if you had a really massive balance, on one side, imagine you have 2,000 loaves of bread or 2,000 pineapples. And on the other side, you have an elephant or a small car, and those balances would be level. They would be equal to each other. So now, using this, so make sure you keep this out so that you can go back and forth if you need to, and make sure that you also keep your anchor chart that shows the different units from lightest to heaviest, because remember, we'll need to look at that as we are converting. Because remember, if you're going from ounces to tons, well, you're going from small to big, so you would divide, but you have to stop at pounds first. You have to add that extra step. If you're trying to go from tons to ounces, well, you're going from big to small, so you're going to multiply, but again, you also have to stop at pounds. You have to add an extra step. So let's go ahead and look at the book, and we will do some practice with this. Okay, so now you should be open in your textbook to page 729. And let's go ahead and read the sentence under the title together. Recall that to convert from a larger unit to a smaller unit, you multiply. So we know that 1 pound equals 16 ounces. So if we know the pounds and we're trying to get to ounces, we would multiply the number of pounds by 16. So if we are going to multiply, we would have to be going from tons to pounds, from pounds to ounces, or from tons to ounces. because either time we're starting with a larger unit and we're going to a smaller unit. Now, we know we have to, go ahead and write this in your textbook, we know we have to divide if we are going from ounces to pounds, pounds to tons, or ounces to tons, because we are going from small to big, which means we divide. So go ahead and write that note to yourself. If we know the tons, we're going to multiply the number of tons by 2,000 to get the pounds. If we know the pounds, we're going to multiply the number of pounds by 16 to get the ounces. If we know the tons and we're trying to get ounces, well then first we have to multiply the tons by 2,000 to get the pounds. And then whatever we got there for pounds, we would multiply by 16 to get ounces. Because remember, if you are moving across, if you are going from the lightest to the heaviest, well then you do have to stop in the middle first. If you know the ounces and you are trying to find the pounds, well then you are going to divide the number of ounces by the number of ounces in a pound. Because remember, you can't divide the number of ounces by the number of pounds in an ounce. A pound is larger than an ounce. That means there are no pounds in an ounce. If you know the number of pounds and you're trying to find the number of tons, then you have to divide the number of pounds by 2,000 to get the tons. Because remember, again, you cannot divide by the number of tons in a pound because tons are bigger, so there are no tons in a pound. If you know the ounces and you're trying to get the tons, well, you know ounces are on one side and tons are on the other. So that means you have to figure out, you have to take the number of ounces and divide it by 16 to get the number of pounds. Then, once you've gotten that, you need to divide the number of pounds by 2,000 to get the number of tons. I don't think we're going to see many, if any, of those today, but it is still something that you need to know if you come across it. Okay, let's go ahead and look at example 1. Okay, everybody finger a pencil on example 1 and read in your head while I read out loud. Lee needs to buy 4 pounds of vegetable burger patties. The table shows the number of ounces in each package of patties. How many packages will Lee need to buy? Excuse me. So we know that she needs 4 pounds, but unfortunately she got to the grocery store and they measure all the packages of hamburgers in ounces. So we need to figure out how many packages she needs. In order to do that, we have to figure out how many ounces are in 4 pounds, because what we are going to be doing is we are going to be comparing 4 pounds to each of these numbers to make sure that 4 pounds is less than the number of packages she buys. So what we have to do, we cannot compare pounds and ounces. We have to get them both into the same unit. Well, it's going to be harder to change the ounces to the pounds just because that's from small to large and we have to divide, and it's going to be hard to divide by 16. So what we are going to do is we are going to change the pounds into the ounces. Remember we had this, I think it was with the capacity lesson, where you compared. And I told you, always change the big unit to a smaller unit. Instead of changing the smaller unit to the big one, you need to get them both into the same unit, change the bigger one to the smaller unit. So we know we're trying to see, so we know we have 4 pounds, and we're trying to see how many ounces that is. Well, pounds are big, ounces are small, so that means we're going to be multiplying. Now let's check our chart to make sure we don't have to add an extra step. Pounds are right next to ounces, so that means we don't have to add that extra step of going to tons because there's nothing between pounds and ounces. So we're going from big to small, which means we multiply. We start with what we know, which is 4 pounds, and then we're we're going to multiply by the number of ounces in a pound. If we multiplied by the number of pounds in a pound, we'd be multiplying by 1 and we'd get 4, which we know cannot be true because 4 ounces would be a lot smaller than 4 pounds. So we have to multiply by the number of ounces in a pound, which, by looking at our conversion chart, we know is 16. Now that's not a basic fact, so we're going to set it up and down each time. So each time today, you need to set it up. If you are multiplying by 16, you need to set it up and down. I'm telling you that right now. So we have 16 times 4. We know when we multiply, we start with the ones place. So 4 times 6 is 24. We regroup the 2 to the tens place. Now we're going to multiply the tens. 4 times 1 is 4, plus 2 is 6. So 4 times 16 is 64. That means 4 pounds is the same as 64 ounces. So now we need to go up to our chart and figure out how many packages of a vegetable burger patty she needs. 1 package has 32 ounces, 2 packages has 64 ounces, 3 packages has 96 ounces, and 4 packages has 128 ounces. Well, we know 1 package is not enough because that's only 32 ounces. She needs 64. 3 packages and 4 packages are way too much because that's 96 and 128 ounces, and she only needs 64. So 2 packages of 64 ounces are exactly 4 pounds. So Lee will need to buy 2 packages. Okay, go ahead and turn to page 730, and then let's look at the sentence at the top of the page. It says, a ton is a very heavy unit of measurement. There are 2,000 pounds in 1 ton. Well, we already know that from our anchor chart. So now we're probably going to be working with tons. So, finger or pencil on example 2, and read in your head while I read out loud. Use the table to find out how many pounds a stegosaurus weighed. Okay, so let's look at the table first. We have dinosaur weights is the title. And then in one column we have the type of dinosaur, and in the other column we have the weight. Now, our problem is asking us about the stegosaurus. So we don't need to know that the Allosaurus weighed 2 tons. We don't need to know that the Megalosaurus weighed 1 ton. We don't need to know Supersaurus weighed 60 tons. And we don't need to know that Tyrannosaurus weighed 8 tons. We're only looking at Stegosaurus. So what we're trying to figure out is, you can come over here and write it up in here, 3 tons is equal to how many pounds? Well, we know the tons, we're trying to find the pounds. Tons are big, pounds are small, so that means we're going to multiply. Now let's check this chart really quick to make sure we don't have to add an extra step. Tons are right next to pounds, so that means we don't have to stop anywhere in between. They're right next to each other, so we don't have to add that extra step. So we already figured out that we're going from big to small, so that means we multiply. Now we start with what we know, which in this case is 3 tons. And then, are we going to multiply by the number of tons in a ton or the number of pounds in a ton? Hopefully you said pounds in a ton, because that is correct. We would not multiply by the number of tons in a ton, otherwise, started to write T instead of 1. We would be multiplying by 1, because there is 1 ton in 1 ton, and we would end up with 3 pounds. Pounds are so much smaller than tons, so 3 pounds is not even close to 3 tons. We have to multiply by the number of pounds in a ton, which we know from our conversion chart is 2,000. Now this is not a basic fact, however, we can use basic facts and patterns. So first, let's pull out the basic fact, 3 times 2, which equals 6, Now let's count the number of zeros at the end of the products. 1, 2, 3. And let's move it to the end, the number of zeros at the end of our factors, which is 3, and then we're going to move it to the end of our product. 1, 2, 3. So that means 3 times 2,000 is 6,000, which means that 3 tons is the same as 6,000 pounds. So a Stegosaurus weighed 6,000 pounds. Remember, this helpful hint shows you basic facts and patterns. You take the basic fact, 3 times 2, it equals 6, and then every time you add zeros to the end of the factors, you also put them at the end of the product. Okay, so figuring out tons is actually one of the easiest conversions that we'll see. So let's go ahead and move on to the guided practice, and we'll do that together. Okay guys, before we start on the guided practice, what I want you to do right now is I want you to get out a separate sheet of paper. Do not be lazy and think, I'm not going to do that, because it's going to make it harder for you. So go ahead, get out a separate sheet of paper right now. You will not need a separate sheet for every single problem, but you will for some. So go ahead and get out a separate sheet of paper, and then we will get started on the guided practice. So the directions say, complete each conversion table. Number 1, we know pounds, we're trying to find ounces. Pounds are big, ounces are small. We know the pounds, we're trying to find the ounces. That means we're going from big to small. Now let's look at our chart and make sure that pounds and ounces are right next to each other. Pounds are here, ounces are right next to each other. We do not have to add that extra step of going between, because there's nothing between. So we already know we're going from big to small, so we'll go ahead and write our equations to the side. We know they are all going to be multiplication, and we know we always start with what we know. Well, we know the number of pounds, so let's add our first factor. We're going to figure out ounces in 2 pounds, ounces in 3 pounds, ounces in 4 pounds, and ounces in 5 pounds. So make sure that's how you would show your work. At least that's partially how you would show your work, because we're going to have to do something else on our separate sheet of paper. Now we need to figure out what we're multiplying by. Are we multiplying by the number of pounds in a pound, which would be 1? Or are we multiplying by the number of ounces in a pound, which would be 16? We're multiplying by the number of ounces in a pound, which is 16. Now this is where your extra sheet of paper comes in, because these are not basic facts. So you're going to go over to your separate sheet of paper, and you're going to start with number 1. Now first, remember it's always easier to put the number with more digits at the top when you're multiplying. So even though we have it like this, the commutative property says it doesn't matter which one comes first. It's just easier to put the number with more digits at the top. So first we're going to figure out 16 times 2. Start with the ones. 2 times 6 equals 12. Regroup the 1 to the tens place. 2 times 1 is 2, plus 1 is 3, which means that there are 32 ounces in 2 pounds. Don't forget, we need the number pair, which they already have for us on that first part. Now we need to figure out how many ounces are in 3 pounds. So again, we're going to come over to our separate sheet of paper, and we're going to set this problem up, and down. Again, I like to put the number with more digits at the top. It just seems to make it a little easier for me. And we'll go ahead and multiply. Start with the ones. 3 times 6 is 18. Regroup the 1 to the tens place. 3 times 1 is 3, plus 1 is 48. So, in 3 pounds, there are 48 ounces. Now we need to figure out how many ounces are in 4 pounds. So again, we're going to go over to our separate sheet of paper, and we're going to set it up and down. Multiply, start with the ones place. 4 times 6 is 24. Regroup the 2 to the tens place. 4 times 1 is 4, plus 2 is 6. So that means in 4 pounds, there are 64 ounces. Now for the last row, we're trying to figure out how many ounces are in 5 pounds. So we're going to go to our separate sheet of paper, and we're going to set our multiplication up and down. Multiply starting with the ones. 5 times 6 is 30. Regroup that 3 to the tens place. 5 times 1 is 5, plus 3 is 8, which means that in 5 pounds, there are 80 ounces. So, let me give you a hint. Anytime you are multiplying by 16, you're going to have to go to your separate sheet of paper. On your homework, on your independent practice, check my progresses, reviews, whatever. If you're multiplying by 16, it is not a basic fact, so you need to go to your separate sheet of paper. Okay, now let's look at number 2. Number 2, we know the tons, and we're trying to find the pounds. We know tons are big, pounds are small. We know the tons, we're trying to get the pounds, so that means we're going to multiply. But before we start setting up our problems, let's check our chart to make sure that they're right next to each other. Here's tons, here's pounds, they are right next to each other, so we don't have to add that extra step in. So now, we already know we're going to multiply, so let's set up our problems to the side, and then we'll see if we need to go to a separate sheet of paper. We know we're going to multiply each time. We always start with what we know, which is the tons, so we're going to figure out the number of pounds in 2 tons, 4 tons, 6 tons, and 8 tons. Now we need to figure out our other factor. Are we going to multiply by the number of tons in a ton, which is 1, or the number of pounds in a ton, which is 2,000? We will multiply by the number of pounds in a ton, which is 2,000. And we're going to do the same thing each time because the number of pounds in 1 ton does not change. Now here, yes, these are not basic facts, but we can use basic facts to solve them, so we don't have to solve this on a separate sheet of paper. For each row, we're just going to pull out the basic fact, and then we'll count the zeros and move them to the end of the product. So, 2 times 2,000, the basic fact is 2 times 2, which is 4. We have 1, 2, 3 zeros at the end of the factors, so I'm going to put 3 zeros at the end of the product, which means that in 2 tons, there are 4,000 pounds. Now I know, try to make this comma where you're separating the number pairs a lot bigger than the comma that just comes in a number that is greater than 999. So you see, I didn't really do, but I can, or if you want, you could do a semicolon. I'm fine with that too. So either make a big dark comma to separate the 2 numbers, or you can do a semicolon, just so that we know that this one is a comma to separate the numbers, and this one is a comma to separate the periods in this number. Now, 4 tons, well, let's pull out the basic fact, which is 4 times 2. That equals 8. We have 1, 2, 3 zeros at the end of our factors, so we put 3 zeros at the end of our product, which means that in 4 tons, there are 8,000 pounds. Okay, now 6 tons. We're trying to figure out how many pounds. Well, our basic fact is 6 times 2, which equals 12. There are 1, 2, 3 zeros at the end of my factor, so I'm going to put 3 zeros at the end of my product. I'm going to place my comma, 1, 2, 3, and now I know that there are in 6 tons, there are 12,000 pounds. Now, last row, we have 8 tons. We're trying to figure out how many pounds that is. The basic fact is 8 times 2, which equals 16. Then I have 1, 2, 3 zeros at the end of my factor. So I'm going to put 3 zeros at the end of my product. I'm going to place my comma, 1, 2, 3. And now I know that in 8 tons, there are 16,000 pounds. Okay, so that's it for the guided practice. However, we are going to do one independent practice problem together. So go ahead and turn the page and look at number 13. Okay, so everybody should be looking at number 13. It says blank ounces equals 11 1/4 of a pound. Now, some of you have figured this out. Some of you may still be struggling with this. I don't know, I just know from calls. But yes, ounces do come first in this equality. However, that doesn't mean that we're going from small to big, because we don't know this small unit. So think of it as the commutative property. We know the big unit, even though it's backwards from what we think, we still know the big unit. So ounces are small, pounds are big, but we know the pounds and are trying to figure out the ounces. So we're still going from big to small. Now, number 13, we need to do on a separate sheet of paper. So go to your separate sheet of paper, and under number 1, go ahead and do number 13. We're going to rewrite the equality. Blank ounces equals 11 1/4 pound. Now we already know, we know the larger unit, we're trying to find the small unit, so we're going to be multiplying. But remember when we did the conversions for length and capacity, first we need to break apart the mixed number. So we're going to break it into the whole and into the fraction. Now, step 1 is to figure out how many ounces are in the whole. So 11 pounds, I'm going to draw a little line here, is equal to how many ounces? Well, we know we're going from big to small, so I'm going to be multiplying. We know that on our chart of just the units, pounds and ounces are right next to each other, so I don't have to add an extra step in there converting it to tons. So I'm going to start with what I know, which is 11 pounds, and I'm going to multiply it by the number of ounces in a pound. So I have 11 times 16. Now, that is not a basic fact, so I'm going to go to the side, and I'm going to set it up and down. 11, let me write it a little bigger. 11 times 16. Now remember, when I have two double-digit products, that means I have to do 2 steps. First, I have to multiply the ones. That doesn't mean I'm just multiplying 6 times 1. That means I'm taking the value of the digit in the tens place in my bottom number and multiplying it by the whole top number. So step 1 is to do 11 times 6. Now, step 2 is to multiply the tens. That doesn't mean that I'm just multiplying 1 times 1. It means I'm multiplying the value of the digit in the tens place in my bottom number times my whole top number, which means I'm saying 11 times 10. Once I'm done, I will add those 2 partial products together to get the final product. Remember, if you're struggling with double-digit multiplication, you need to go ahead and practice some IXLs. You do not need to finish them. You just need to work on them to the point where you are comfortable with this, because you'll be seeing it more and more. Now, let's start with step 1. 11, we're multiplying the 1. So 11 times 6 is 66. That's a basic fact. We know 6 times 1 is 6. 6 times 1 is 6. Now, 11 times 10. We know any time we're multiplying by a multiple of 10, our digit in the ones place will be a 0. Now we're just going to figure out 11 times 1. Well, 1 times 1 is 1, and 1 times 1 is 1. So our partial products are 66 and 110, and now we're going to add them together. 6 plus 0 is 6. 6 plus 1 is 7. Nothing plus 1 is 1, which means there are 176 ounces in 11 pounds. But we're not done yet. We finished step 1. Now we need to do step 2. Make sure you have step 1 written because, well, no, I'm going to do, trying to figure out where I can put this because I don't really want to erase. I'm going to have to. Okay, so I know I'm going to just erase my work. I'm going to leave this, but I'm going to erase my work. You should have that in your, on your separate sheet of paper. So now I know step 1, 11 pounds is equal to 176 ounces. But now I have to do step 2 because now I have to figure out how many ounces are in 1/4 of a pound. Well, I'm going to do it the exact same way. I know pounds are bigger than ounces, so I'm multiplying. I'm going to start with what I know, which is 1/4, and multiply it by the number of ounces in a pound, which is 16. Remember, to multiply by a fraction, you multiply just the numerator by the whole number. 1 times 16 is 16, and then the denominator stays the same. So I have 16/4. That's an improper fraction. I can't leave it like that, so I need to convert this improper fraction into a mixed number. Remember, to do that, okay, good. I thought I was blocking it. To do that, I divide the numerator by the denominator. 4 can't go into 1, so I need to move a digit over. 4 goes into 16 4 times. 4 times 4 is 16. 16 minus 16 is 0, which means 16/4 is equal to 4. That means 1/4 of a pound is equal to 4 ounces. So I've done step 2 and I figured out that 1/4 of a pound is equivalent to 4 ounces. And step 1, which told me that 11 pounds is equivalent to 176 ounces. Now I need to erase to have room for step 3. You do not have to erase. You should have that written on your separate sheet of paper. And now I'm going to move on to step 3, which is where I add the number of ounces in my whole number, which is 176, to the number of ounces in my fraction, which is 4. 176 plus 4, well, we can just count up. 176, 177, 178, 179, 180. So that means 180 ounces is equal to 11 1/4 of a pound. Okay, that's all we're going to do together. If you have any questions about any of that, make sure to reach out to me later today. However, if you have these written down, then you can go ahead and do them and just replace the numbers with whatever numbers are in your problem. That's why we have all these examples, because you're going to be doing problems that are just like example 1, example 2, the guided practice numbers 1 and 2, and number 13. And each time, all you have to do is follow the exact same steps, just with different numbers, because you're going to be given different numbers every time. So now let's go ahead and look through the independent practice in the homework so that I can tell you exactly where to look for what steps to follow to solve the problems. Numbers 3 and 4 are exactly like numbers 1 and 2, just with different numbers. So you're going to do the same thing that you did on number 1, on number 3, and on number 2, on number 4. Numbers 5 through 13 are just like examples 1 and 2, but remember, we set it up the way you're supposed to here. You only have to do the one step unless you have a fraction, or if you have to stop at pounds if you're trying to go between tons and ounces or ounces and tons. Number 14, you're going to have to do a little bit of work to figure out which one is correct. Some of them are correct, one of them is correct, the rest are not. You need to figure out which one that is. Numbers 15 through 17, pay close attention to what I'm going to say. You are doing conversions just like numbers 5 through 13, but you need to pay attention to the wording. Because for some of these animals, their birth weight is a range. Remember, a range means it can be anywhere from one number to another number, so they show that by having a number, then a dash, then a number. The giraffes, giant pandas, and walruses all can weigh between a range of ounces. So that means at the least, they weigh that first number, and at the greatest, they weigh that second number. So for number 15 and 16, you see that you are being asked about the least or the greatest weight of a baby animal. So make sure that you are looking at that range and you are finding the least number in the range and the greatest number in the range. Now, numbers 18 and 19 are reasoning and critical thinking. That means you need to use what you know to figure out the correct way to solve a problem, and then you need to use what you know and what you learned today to come up with a brand new answer. Make sure that you are actually thinking this out. I've noticed on a lot of critical thinking in mostly I only see science and in reading that a lot of you are just you're not even thinking about the question. You're just kind of reading the question, maybe thinking about it for a second, and then writing an answer. It's really hurting some of you because you're losing all the points. Some of you are even writing answers that have nothing to do with what the question is asking. So you've got to think about these. You are not going to be able to answer every question right away. In fact, the older you get, the higher up in school you get, the less the answers come to you right away, and the more you have to actually think. So get used to that now so it's not as hard later on. Okay, now let's look at the homework. Numbers 1 through 4 are just like these problems. Numbers 5 and 6 are just like step 2 of number 13. Numbers 7 and 8 are just like the guided practice. Numbers 9 through 11 are word problems where you're going to be doing conversions, so make sure you have numbers and units in that problem. Do not forget units. You will lose points. Some of you have been doing really well on your homeworks with doing units. Some of you have not, and you're losing points for it. Make sure if there's an explanation that you have an actual explanation. Anytime you're doing the conversions, you need to show that multiplication problem. Remember, if you're multiplying by 16, you need to show it on a separate sheet of paper. If you are multiplying, so your multiplication problem should just go right underneath the problem. So, if I was doing this one, well, I know tons are bigger than pounds, so I'm multiplying. I know 3 tons. I know there are 2,000 pounds in a ton, so that's all you need to write here, and then you can solve it right here. So for every problem, unless it has a fraction, in which case you'll do the whole thing on a separate sheet of paper, you need to have that problem underneath. If you're multiplying by 16, you need to show the work on a separate sheet of paper. So for any of that, the homework or the independent practice, if you have any questions on that, please reach out to me today between 1 and 5, and I'll help you out.